Hello everyone, this is Ömer Karagüzel from School of Architecture, Carnegie Mellon University. Now this is the second tutorial on HVAC system development using Design Builder's advanced functions. And this tutorial is again on VAV Reheat with water-cooled chiller HVAC system. In the first tutorial, we work on how to create system configuration, say HVAC topology, and we did it as you can see here in the user interface. And in the second tutorial, we will work on modifying some of the HVAC system component parameters and the properties and the features. Of course, we will keep many of the input parameters at their default values, or we are going to use Energy Plus's auto-sizing features at most of the parts. But there are some points that we need to touch and change to make a more reasonable system development. So, I will start with changing some properties on HVAC zone data. When I click on one of these perimeter zones, for example, and I double click on one of the floors and I right click and say edit, and I see this screen, and this is HVAC zone data. Now, in the HVAC zone data, let's get it larger. The first thing is thermostat heating set point schedule and the thermostat cooling set point schedule. These two things are very important. And when we look at the assigned schedules here, heating set point schedule, and click on it and click on the edit, we see a typical schedule assigned. But look at here, it is for all days until 24, and it is 20 degrees Celsius. This is not a reasonable value. There is no setback here. A set point temperature is assigned all days, weekend and weekdays and holidays, and for all hours of the day. So there is no setback here, and this system using this heating set point will not be working efficiently and using a lot of heating energy. And similarly, cancel this, look at the cooling set point and click edit. It is 24 degrees Celsius for all days until 24 means each hour of the day. It is 24 degrees Celsius. These are not reasonable. So your job is to have a look at Design Builder's extensive schedule library, okay, and choose an appropriate schedule for heating and cooling set points from the library, or create your own library, create your own schedule, and add your schedule to the library and select and assign and change the thermostat schedules. Please pay utmost attention to choose the right schedules at this point. And we are not going to touch PMV set point schedule, thermal comfort schedules, or we are not going to assign humidistat control, humidification or dehumidification controls, or we are not going to do CO2 or contaminant control. But for the cooling sizing and heating sizing, we will change the temperature difference to temperature difference and provide 11.11 degrees Celsius for both. Just do this, and then scroll down and you will see outside air sizing inputs, and this is another crucial step that you need to take care of. This is the outside air, ventilation air requirement, and there are different input categories: flow per person, flow per zone, flow per area, sum or maximum. Look at the sum. There are two values you need to find from relevant sources like standards, like ventilation standards, ASHE 62.1 for example, and you will find the values. And if conversion is needed, you need to convert the data, find the right unit of measurement, and you need to provide the data here and here. For example, here outside airflow per person, meter cube per second per person, and outside airflow per zone area, meter cube per second per meter square units. So you need to find these and provide for each different zone type. Are we going to do the same setting and modification differences for each and every zone? No, there is an easy way to do that. This is target automatic applications. You can choose the type 1 just for this HVAC zone, save the changes, or you can choose multiple HVAC zones, save the changes, so you can select west, north, and south. So all the changes you did in this dialog box will be automatically applied to all the selected zones. It is under your control. You can deselect or select the zones that you want. I will select all of these, or just click this, select all of these, say OK, and all the settings will be applied to the other zones as well. For example, look at the west, right click and edit, and see the changes are already applied. So these are the things that you need to do with the HVAC zone data. In the HVAC zones, in the terminals, we see this component VAV Reheat, right click edit, and not much to change. In fact, nothing to change at normal conditions. The only thing that you can focus on is this reheat coil's maximum reheat temperature, which could be increased if, in case, the time set point not met values are too high for this specific terminal zones. If this is too high for this zone, you can go in and look at the maximum reheat temperature and increase it beyond 35, maybe 40, 42, 43, something like that, to get rid of some time set point not met value problems. But normally we don't need that. Just as an example, I'm just showing it to you. The next setting is about air handling unit, okay, AHU. So I'm going to say perimeter AHU, and then first just right click on the VAV perimeter, and this is sizing of the VAV system. Most of them is auto sized and there is nothing to change. See, minimum system airflow ratio is 0.3, which means 30%. Minimum outdoor air is set, and the remaining inputs are fine, so nothing to change. So I will close this. The things that we are going to touch are related with this set point manager. I can double click and just choose it and click edit. This is the air loop set point temperature. Normally it is scheduled, when I look at the schedule, I see always 14 degrees C, which is not again very efficient, which is a fixed schedule. So I will change it to warmest, and the warmest type has a minimum and maximum set point temperature. Now it's 16 to 11, minimum is 11, maximum is 16. So keep it as it is and choose the warmest. Okay, and you can read more about what does it mean, this warmest, from here. And it's basically giving a more flexible controls based on the cooling load of the warmest zone, terminal zone, and adjust the supply air temperature accordingly, which is more flexible, which is more efficient. So you should do this at the set point temperature. And then the next thing is going to do AHU. Right click edit in the AHU tab. Now design flow rate is auto sized, of course. Availability should be on 24/7. You can click on the night cycle, okay, and night cycle should be on, availability always, and you can select control type control on any, and you can change the cycling ground time to 3600 to 1800 seconds. Just decrease it to half. Okay, this night cycle is related with the operation of the system fan, supply fan, and extract fan during off office hours or off time or night times. It may not be night time, but the terminology is like that. The systems are not continuously operating. They are kind of cycling between on and off operation based on the requirements, based on the loads imposed by setback temperatures, not the set point, of course. So this again, to save energy, not turn on the fans on all the time, just cycle them, but the control is on cycling on any one of the terminal zones. Okay, if any one of them requires some heating or cooling, the system fans will be kicked on and they will operate to satisfy the zone's terminal needs. So that's it. And look at the outdoor air system. Things are fine, but see, there is no economizer. Let's choose a fixed dry bulb economizer. Okay, and then there's an economizer which provides free cooling during the times when outdoor temperature is right. Here there's a setting here. It's called economizer maximum dry bulb maximum limit dry bulb temperature setting, or let's say it is outdoor dry bulb temperature high limit shut off control, and it should be around not 25 but 21.11 degrees. That's it. So it's a high limit control. It's a cap, or it's a limitation at the top. So the maximum is 21.11. That's it. Say okay. So these are the things that you need to do with this main AHU system controls and the air loop set point temperatures. And how about the fans, supply and return fans? Now if I click on the fan here, right click and edit, and I can see the properties and what has to be provided as an input. First of all, fan total efficiency 0.7 is too large, reduce it to 0.6, and pressurize, just put 1200 pascals. And again, this pressurized value is a little bit of rule of thumb, calculated out of rule of thumb values. And for central mechanical ventilation, including heating and cooling systems, is about these ranges. The exact value can be optimized or fine-tuned based on the system requirements, the flow rate requirements. But again, this is beyond the scope of this assignment. It will put too much burden on your side, so we will choose a ballpark value, which is okay, but you can read more about finding this pressurizers on Design Builder's help documents. Other than that, we will look at this part load performance curves. There's a template assigned. Please click on it and choose fan part load power curve to this Asia 90.1 2007 Appendix G curve. Just double click and you see the red letters assigned, and it's done. And I did it for the supply fan, and I go ahead and choose the return fan or extract fan and change the value again 0.6. And again, you should choose the same pressurized value. Click on the performance curve template, choose Appendix G's template and say okay. Fine, fans are done. So heating and cooling coils, anything to do with these? Not much. They are already auto-sized and the inputs are fine, so I don't want you to touch these. Again, the cooling coil, have a look at it. Many of the things are auto-sized, water-based, always available, control variables, temperature, fine. So these are okay, no need to touch. So we finished our work with the air loop. But don't forget, I did this for the perimeter zone VAV AHU. You should repeat it for the core zone VAV, or maybe you have 4, 3, 4, 5 AHUs, right? You should repeat them for each one of those. Please do not forget to update all the air loops, all the HVAC, all the AHU systems that is existing in your HVAC system. Now, we should go to the hot water loop, HW loop, and then in the loop, we should focus on first the set point temperature. So we should go to the set point temperature manager and right click edit, and you see now it is scheduled. When I look at the schedule, I see it is about 80 degrees Celsius all the time, always, again, which is not totally efficient and it's kind of rigid, not flexible. So we'll choose this type 10 outdoor air reset. Okay, in the outdoor air reset type, there are 4 inputs needed, and I'm going to put these values, new values, 82.22 minus 6.67, and then what else, 65.56, and then 10 degrees Celsius. So we have 4 values to fill in, and we provide these new values. Set point at low temperature, outdoor low temperature, set point at high outdoor temperature, and outdoor high temperature. These should be defined separately. Say okay. The next job is go to the pump. So recirculation pump, hydronic recirculation pump, and now motor efficiency 0.9 is too much, change it to 0.7, and the rated pump head in terms of Pascal, in terms of, this is pressurized again, rated pump head should be around 1600 ranges. So let's provide this value as a pump head and not touch any other thing. And then let's go to the boiler, select the boiler, right click, edit, and in the boiler now, let's have a look at it. It is a condensing boiler. No, we would click on it and choose Asia 90.1 Appendix G baseline boiler. Natural gas, not modulated again. But look at the nominal thermal efficiency, 1.0. That's too much. That is unrealistic. We should change it to 0.8. So 80% nominal thermal efficiency is again a baseline value. You can find more than that, in the real applications, but now it's kind of a baseline model. And we are partly following the baseline assumption, so we said 0.80 is a good number. Say okay, and that's it. That's all we did with the hot water loop. What about the chilled water loop? We should go to the, again, this set point temperature manager and click on it. Manager data. It is scheduled. When we look at the schedule, it's always 6 degrees. Not that efficient. Change it to outdoor air reset, and you see set point at outdoor low temperature, outdoor low temperature, set point at outdoor high temperature, and outdoor high temperature. 4 values. Now they come in as default. No need to change. Just keep them the same as you see in the screen. No change is required. Say okay, and then go to the pump, supply pump, and edit. What about the pump, loop pump? Again, it is 0.9, it's too high. Change it to 0.7. Pump head is a little bit low, in fact very low, and change it to this value. Okay, and things should be fine. Say okay. How about chiller? Is something to do with the chiller itself? Not much. Yes, you can just keep this typical DO2 centrifugal chiller 5.5 COP. Okay, we will keep this the same. The chiller COP same between VAV and CAV types. Do not forget about this. Yeah, the condenser loop is changing between air-cooled or water-cooled, but the chiller itself from the template should be DO2 centrifugal chiller 5.5 COP. So again, the other inputs just the same. Don't change. No need. Oh, yeah, just one thing. When you open it, the program gives a little bit of a bug. It says minimum unloading ratio must be greater than equal to the minimum part loading ratio. Then I say minimum part loading ratio is 0.1. This is 0. I will increase it to 0.1. And okay, fine, no harm. Just a little bug in the program. It's doing this. But okay. So again, chilled bottle is done. What about the condenser loop? Again, we should go to the same elements. Change to set point manager data, and then now for this condenser loop, just a second, follow outdoor air temperature is good, but we should choose outdoor wet bulb. And in the outdoor wet bulb temperature, min-max settings, minimum we should supply 21.11 and the maximum 29.44. Okay, reference temperature is outdoor wet bulb. And here are the maximum and the minimum values that you have to provide. Say okay. Go to the loop pump, and the pump related with pump, the same settings 0.7, but this number is different. Pump head for the condenser loop should be higher, right? Should be higher. It should be around 235,000 pascals. Okay, and even there is a decimal points. Okay, so I provided all the data here. The rated pump head and the motor efficiency is done. Say okay. Fine. How about the cooling tower? Just click it, right click, edit, and then in the cooling tower, it is single speed. Just select it and change it to double speed. Double speed cooling tower is fine. How about the rest? No change. Just keep them as in the default inputs. So say okay and done. So this is with the condenser loop. Okay. So the only remaining element that we didn't touch is this domestic hot water system, DHW loop. So in the DHW loop, we have the water outlet group, right? The water usage. So if we edit the component, now have a look at this. It is a set point temperature. Currently it is always 55. Okay. You can accept it. You can choose a different value. For example, here I have another always 43.3. I choose this new temperature schedule. Again, the required temperature at the water outlet, this is the faucet, this is the tap, this is the water coming out of the use side equipments, can be different. For example, kitchen equipment, it can be 49 degrees C. For laundry and dishwashing, it could be 60 degrees C. For offices, guest rooms, or school hall rooms, and some the service places for such type of buildings,
it can be 43.3. So that's why I choose this value. How about peak flow rate? It's meter cube per second. Yes, you need to adjust it. This may not be reasonable, and you can find in the literature what the peak flow rate is a very important input. And if you find some values in GPM, please pay attention to convert them to SI units, which is meter cube per second. And the remaining input, and very important input, is the flow rate fraction schedule. Right now it's on 24/7, again, which is not reasonable, right? 24/7 on is very inefficient and unreasonable. Please pay utmost attention to adjust it. Find some representative schedules from Design Builder library or from literature. You should find that, because this means that it's always on. The water is always flowing from the faucet. Now, it's not reasonable. And if you leave it as unchanged, untouched, at the end of the simulation, you will get a lot of water heating energy consumption. Okay, you can even equal similar values to the total space heating energy consumption, and this is a big error. Please check it and change it and apply a reasonable flow rate fraction schedule to here. Okay, how about the loop? Look at the loop data, say edit, wait a little bit. And the loop is water, fluid type is open, water, variable flow. The only thing you can change here is just change the hot water loop exit temperature to 60 to be on the safe side in terms of system sizing, okay? And nothing more than that, just 60, design loop exit temperature, and say okay. Okay, let's go to set point manager. Here we have anything to do with the set point manager. It is scheduled and it is always 55, but remember I changed the required temperature at the water outlet to 43.3, so I should change it here. It is scheduled always 43.3. Say okay, that's it. Let's go to the loop pump and edit. In the loop pump, similar to what we did the other pumps, 0.7, and the rated pump head is similar to the hot water loop. Okay, just input this value and you will be safe and ready to go. Have a look at the hot water heater properties and tank volume, of course auto sized, you don't need to touch it. The only thing that's important here is the fuel type. It's not electricity, choose natural gas, and then decrease nominal thermal efficiency, or they call it heater thermal efficiency, to 80% efficient, like in the baseline design. It's coming from ASHA 90.1 standard again. So, and temperature settings, set point temperature schedule, again, it is left in 55, but I should change it to 43.3. Okay, so say okay, no more changes, and that's it. And please do not forget, you may have multiple water outlet groups, so you can add more outlets and you can connect and you can make the changes again. But as you make changes, since system is auto sized, the size of the entire water heating system will be changed and will be different. So with all these inputs, we did the minimum modification requirements that you have to conduct on VAV Reheat water cooled chiller, and apply it and show it to you in this tutorial. And I'm checking my data and I think we don't have anything more to change. That's it, guys. So I hope it could be helpful for you, but do not forget about that you have to create a CAV system as well, including its plant loops and air loops and domestic hot water system. You should keep the domestic hot water system exactly the same in these two CAV versus VAV system. We don't want to see a change in the domestic hot water system specifications, but the others will be different, of course. Okay guys, I hope it could be helpful. That's it for our second tutorial. Thank you for listening.